Okay. Yeah, we would like to welcome you back to this YouTube channel. The name of the channel is Physical Sciences Silver Bullet, and the voice behind is Richard. So today we want to look at this question. It's going to be it's going to cut across a number of very important areas in electrical circuits. So when you look at this is our first question. We are having our voltmeter here. This is the main circuit with the ammeter. Then we have this parallel connection around here. So we are going to have a number of questions on this very circuit, which will be very educative. Before we start, I would also urge you to subscribe so that you don't miss a number of our videos which we'll be posting. We want to assure you that all the chapters and all the areas will be touched. So we would urge you to stick with us. You'll not regret. There comes our question number 1.1. We are supposed to calculate the external resistance of this circuit. So let's go back to work. So when you look at this circuit, what do we notice? We notice that there are two clusters of resistors, and this is the easiest way of dealing with this. We have this resistor here, that's the first cluster, and then we have another pair of resistors here which make the second cluster. So those are the two types of clusters of resistors here. So those are the resistors which make up the external circuit. So what do? We say our total resistance is going to be equal to our resistor, which we'll have in series here. We are going to call it RS, and our pair of resistors here, which make up the parallel connection. So these are the resistors we are having, and we already know some. Okay, we know this. It's given. It's this 5. So we are going to have our RT equals to our 5, because that one is already known, plus our RP. So our parallel resistor is also known, though it has to be calculated. So we can simplify by saying calculating RP, because it is very clear here that when we get our parallel resistor then and we substitute there, then we can get our total external resistance of the circuit. So what do we say here? We are having two branches of the parallel connection. There's this branch which has that 6 ohm. Remember that the formula for calculating the parallel resistance is 1 over R1 plus 1 over R2. We've been doing this one all along. So we know already this one. So I'm going to say 1 over RP is equal to 1 over 6. That one is already registered. Then we have a problem. We have this branch of the parallel connection. and it has these two resistors. How do we deal with them? Now, if they are in the same line, they are in series. And what do we know? We know that resistors in series are additive to get the final resistor. So what do? We are going to add these two resistors here to get one resistor which represents them. So when you add 4 and 3, we are going to get 7. So that is it. So from there, then calculation proceeds. So what do we get here? We are going to get 1 over Rp is equal to, after computing here, we get 13 over 42. So after getting that, what do we know? This is what we know, that this resistor is inverted. So what we normally tell our learners is that you don't have to cross multiply here. You just flip the entire equation such that what is the numerator becomes the denominator, and what becomes the denominator, what is the denominator becomes the numerator. So what are we going to get? We are going to get Rp, which is Rp over 1. Actually, any number is in the world is over 1. Then you get 42 over 13. This gives you our Rp, which from the calculator is going to be 3.23 ohms. So there we are. We just got our Rp. So what do? We substitute it where it's supposed to go. So we come up with our RT, or total resistance, as 5 plus 3.23, giving you 8.23 ohms. That is our total external resistance of this circuit. There comes our next question. It reads, calculate the ammeter reading A2. Now, what you have here is our A2, this one is what we need to find. Now, you have to know that A2 is in the second branch of the parallel connection, and we have the first branch of the parallel connection, which is this one. So these are the two branches we have. Then to solve this question, you need to bring in the concept of the parallel connections. And what does it say? It says that parallel networks or parallel components have the same voltage, stroke what? Potential difference. So in other words, these two arms of the parallel connection, this side and this side, they have the same voltage. And what do we say? From the Ohm's law, we say that potential difference or voltage is given by IR. So if this side and this side are equal, then we can say Vp, which is the potential difference across this parallel network, is equal to V across 6, which is also equal to V across, let me call it across 7, because we combine these two. Then remember, we have just put across this equation. So what can we say here? So here we say potential difference across 6 is equal to potential difference across 7, and every V is equal to IR. So we can say I through 6 times R through 6 is equal to I through 7 times R through 7. And what is remaining is to just substitute. Remember, this arm is known. We know the current going through the 6 ohm resistor. And that is, it was given here, it's 1.8. And we know the resistor, it is 6. Now, with this arm, what do we know? We don't know the current, it's what we are looking for. But we know the resistance, total of the two is 7. So from here, we perform our normal calculations and we get the answer. So after calculations, this is what we get. Our answer is that it is 1.54 ampere. So that one has been solved. So let us go to the next question. Then comes the next question, which is 1.2.2. It says calculate the ammeter reading A. And this is the A we are talking about. Now, when you analyze A very well, you'll see that A is standing in the main body. So from here up to here, that's the main body of the circuit. And any ammeter put in this part of the circuit will read total current. So in other words, what the question is indirectly asking for, total current going through this part of the circuit, going through the battery as well. So under this circumstance, what do we do to get this? So you have to remember that there are two ways. One of the way is a dead end. One way is to get total voltage and total current and total resistance and use Ohm's law, but it will not work here because we don't have the terminal voltage. So we can use another method. So in this case, you have to remember that we know the current through this arm of the parallel network. We also know the current going through this arm. Now, this is what you have to remember about the flow of current. We have the positive terminal here. Our assumption that current comes from there, that's the conventional current. So when it reaches this point here, it branches into two, it divides into two. Part passes here and part passes here. There are only two branches we have here. So after that, what happens? When it reaches this side, it combines and goes back into the circuit. So from that explanation of the flow, we can as well tell that if the current we have here is total current. And part of the total current passed here, we can call it I1. And part of that one passed here, and we can call it I2. Remember that we are having only 2 branches which are dividing this current. So we can as well tell that total current in this aspect is equal to I1 going through the first branch plus I2 going through the second branch. Now, both of them are known. I1 was given to you. It is 1.8 ampere. So for I2, let us leave the I2, we have just calculated it. And what did we get for I2? Let me recall. So our I2, which we calculated previously, it is 1.54. So the sum of the two will give you the I total we are looking for, the total current which goes through that ammeter or through this main board of the circuit. So this is the answer we have been looking for. Then we are going to go to our next question, but to cut the video short so that it doesn't become very long, next question is going to be answered in the next video. So for now, just go to the next video and check the next question.